For the proportion, we know we use cross multiplication. So 6 needs to multiply x plus 9, and 9 needs to multiply 9. So 6 times x plus 9 is 6x plus 54. Don't forget to distribute. 9 times 9 is 81. At this point, it's a normal equation. Subtract 54 from each side. So 6x is going to equal 27. Divide both sides by 6. We notice that 27 is not divisible by 6, but each are divisible by 3. So we're going to reduce, and we're going to have 9 halves. In problem 16, you could immediately cross multiply, but I happen to notice that 6 and 8 can reduce to 3 over 4. If you can get in the habit of noticing those kinds of things, it makes all the numbers a little smaller, which makes the problems a little bit easier. Again, we want to cross multiply because we have a fraction equal to a fraction, which sets us up for a proportion. So 4 times x minus 5 is 4x minus 20, and 3 times 2 is 6. From there, we can add 20 to both sides. So 4x equals 26. We can divide both sides by 4. And again, 26 is not divisible by 4. But since they're each even numbers, we can reduce by 2. So 13 over 2 is our final answer. Taking a look at number 17, when we cross multiply, we see that 8m equals 5m minus 15. Subtracting 5m from each side to collect all the variables on one side, we have 3m equals negative 15. Divide both sides by 3, and m equals negative 5. Cross multiplying, we see that 5x is equal to 10x plus 40. We want all the variables on one side. You have two choices. You can subtract 10x from each side, or you can subtract 5x from each side. Normally, I would tell you to subtract 5x from each side because that would keep the x's as positive as possible. But if we do that, we end up with all the terms on one side of the equal sign, and we're going to have an extra step of moving the 40. So in this case, I actually think it's a little easier to subtract 10x from each side. So we have negative 5x equals 40, and we divide both sides by negative 5 to get x equals negative 8. Just in case you're wondering, if we do what I mentioned a moment ago, if we take 5x equals 10x plus 40, and we subtract 5x from each side because that will keep the x's positive. See how we have positive x plus 40? You have to remember that this side of the equation does not disappear. We have a 0 over here. So we can subtract 40 from each side. So negative 40 equals 5x, and divide both sides by 5, and notice we still find out that x equals negative 8. It's the same answer no matter which way we do the problem. Taking a look at problem number 19, we cross multiply to get that 3x plus 6 is equal to 2x plus 16. If we subtract 2x from each side, we'll have a positive x plus 6 equals 16. Subtracting 6 from each side tells us that x is equal to 10. Cross multiplying in number 20 gives us 3r minus 24 equals 5r plus 45. Subtract 3r from each side because it's the smaller amount of r's. So negative 24 equals 2r plus 45. Then we can subtract 45 from each side to try to move things away from r. So negative 69 is equal to 2r. Dividing both sides by 2, we have an odd number in our numerator, so this cannot be reduced. We just have negative 69 over 2. Next, we get into word problems that are still using proportions. Hugh's boat used 5 gallons of gasoline in 4 hours. At this rate, how many gallons of gasoline will the boat use in 10 hours? All right, we have gallons and hours. So 5 gallons being used in 4 hours. That means we need gallons and hours to be set up the same way on the other side. Notice the problem tells us 10 hours and asks us to find out how many gallons. So we use our units to make sure we're setting up the problem the same way, but we don't need them to actually do the math. So I'm going to sneak them back out of there. Cross multiplying, 4x is equal to 50, and when we divide by 4, we get x equals 25 halves. Now, you all know that I typically just want a fraction as an answer. But this says how many gallons of gasoline per hour, and that's a little bit confusing to say 25 halves gallons per hour. So this might be a time that we could switch to a mixed number and say 12 and a half gallons per hour to give an answer that sort of makes sense. Oh, actually, it's not gallons per hour. I'm going to back that up. It's just 12 and a half gallons because it says how many gallons will it be used. All right, Tori paints a room that has 400 square feet of wall space in 2.5 hours. Now, first of all, we can't really do any math with a mixed number. So 2.5, remember you say 2 times 2 is 4 plus 1 is 5. So this is 5 halves. At this rate, how long will it take her to paint a room that has 720 square feet of wall space? Okay, so if we have 400 square feet in 5 halves hours, we're going to need square feet over hours for the other side of our proportion as well. Notice the information they give us is 720 square feet, and we're asked how long, so this is what we don't know. Once I've used the units to set up the proportion, I can take them out so that they're not distracting me while I'm solving the problem. I'm going to write this next step out in a little more detail. We have 5 halves times 720 equals 400x. Remember, when you have a fraction times a whole number, it's often helpful to imagine that whole number being over 1. Now I can see that I can reduce 720 by 2 to get 360. So 360 will multiply 5 to give me 1800 equals 400x. We can divide each side by 400. Notice these zeros drop. 18 and 4 are both divisible by 2. So x is equal to 9 halves. Now, remember what this is an amount of time. The problem originally was in mixed numbers. It might make sense to change this to mixed numbers. 9 halves is 4.5 hours. We have another word problem that we can also solve with a proportion. Sophia is baking for a big event. She knows the recipe calls for 3 teaspoons of vanilla for 8 cups of batter. So we have 3 teaspoons for 8 cups. So I'm going to need teaspoons over cups on the other side as well. How many teaspoons does she need for 30 cups of batter? I used the units to figure out how to set up my proportion. Now I can remove them and just focus on the numbers for doing the math. 8 times x equals 90, dividing both sides by 8. I can see that those are both even numbers, so 45 over 4. Now, that's a pretty awkward way to describe how many teaspoons we need. If we look at that, we can see that as a mixed number, that's 11 1/4. So we would probably say that there are 11 1/4 teaspoons, since quarter teaspoons are a type of measuring tool that we could actually use. Next, we have absolute value equations. In the first problem, the absolute value is already alone, so we do not have to isolate it. And we can go straight to writing the two equations. N minus 5 equals 11, or N minus 5 equals negative 11. Remember, it's the number outside that changes its sign. The thing inside the absolute value stays the same to form the left-hand side of each equation. So we're going to add 5 to each side. We have N equals 16. And then we add 5 to each side, and we have n equals negative 6. Notice those numbers are not the opposite of each other, right? 16 and negative 6, although they have different signs, they're not the same number with different signs. So it's really important that we solved those two equations separately. We didn't just ignore the absolute value and try to stick a negative on it. In number 25, we also have a situation where the absolute value is already alone. So we can go straight to writing the two equations. 8a plus 4 equals 68, or 8a plus 4 is equal to negative 68. We need to solve both of these equations. I'm going to do them both at the same time because it's the same steps. You can choose to do them at the same time or to do them one at a time. I've subtracted 4 from each side. For the left equation, that gives me 8a equals 64. And for the right equation, that gives me 8a equals negative 72. Then I need to divide both sides by 8. So a equals 8 on the left. On the right, we have a equals negative 9. There are two solutions. For each of the next two problems, there's some stuff outside the absolute value. So we can't go straight to rewriting the equation. First, we have to isolate the absolute value. So we have the absolute value of 2x plus 2 equals 10. Now that the absolute value is alone, we can write the two equations. 2x plus 2 equals 10, or 2x plus 2 equals negative 10. If we subtract 2 from each side, we have 2x equals 8 and 2x equals negative 12. Dividing both sides by 2, we have x equals 4 or x equals negative 6. Number 27 is very similar. Start by subtracting 8 from each side since it's outside the absolute value. So the absolute value of 1 minus 3m is equal to 17. Now we can write the two equations. 1 minus 3m equals 17, or 1 minus 3m equals negative 17. If we subtract 1 from each side, we have negative 3m equals 16, or negative 3m equals negative 18. Dividing both sides by negative 3, we will isolate the m. Oops, don't want to move it, just want to make it smaller. There we go. So m is equal to negative 16 thirds because that fraction can't be reduced, or m is equal to a positive 6 because that fraction can be reduced. Next we have in 28 a slightly more complicated absolute value equation. First we need to subtract 2 from each side, so we have the negative 6 is equal to the absolute value of 3 minus 8r equals negative 18. We still have another number outside the absolute value, so we're going to divide both sides by negative 6, and we have the absolute value of 3 minus 8r is equal to 3. Now we can set up the two equations. 3 minus 8r is equal to 3, or 3 minus 8r is equal to negative 3. We can subtract 3 from each side, and we see that negative 8r is equal to 0, or negative 8r is equal to negative 6. Don't panic when one side of an equation is equal to 0. Divide both sides by negative 8, and r equals 0 because 0 divided by anything is still 0, or r equals, notice a negative divided by a negative is a positive. 6 and 8 are both even, so we reduce by 2 to get 3/4. And the last problem, we're going to start by subtracting 4 from each side. Negative 5 times the absolute value of negative 7x minus 1 is equal to 75. Dividing both sides by negative 5, we have the absolute value of negative 7x minus 1 is equal to 75 divided by negative 5, negative 15. Now at this point, we should notice that this doesn't look right. Notice you have the absolute value of something being equal to a negative number. And we know that when you take the absolute value of any number, you end up with a positive number. So this is not possible. So we stop here. We don't need to solve any further, and we can say that there is no solution.